It's an extremely controlled environment. The clean rooms are controlled to the same standard that an industry lab would be. We have the same clean room disciplines, we have the same gowning disciplines, and also we have equipment which is very much comparable to the type of equipment which is used in industry. The FlexiFab at Tyndall offers probably up to about technology readiness level 7, which is very, very high on the general scale of things.
So Intel has several research projects with the Tyndall Institute, and the variety and number of projects has been increasing each year. For many of these projects, the Tyndall FlexiFab provides the capability for the practical experimentation needed in the work, which enhances the value of the research projects here at Tyndall. Research on new and experimental materials can be carried out in a controlled environment by people skilled in the operation of the equipment, working with fab standard equipment. When working on novel processes and materials, the Tyndall FlexiFab allows many different approaches to be tried easily and in a very cost-effective manner.
CMOS has been the mainstay of technology development for many years, but we need lots of new types of functions from materials, such as in the internet. You need photonics to send signals over the internet. First, you like to look at solid-state lighting. That needs new materials to create light from the semiconductor. So as a result of that, we've had a big change in the types of materials that we need to work with. So Tyndall FlexiFab has a wide range of tools which allow us to construct the devices as we want. So particularly we have tools that allow us to do lithographic processes. So those allow us to control the dimensions to sub-micron scale. We have very specialized etching tools that allow us to control the profile of the materials. And we have very specialized metallization tools which allow us to evaporate some very high melting point metals, such as, for example, vanadium, or tungsten, both of which are used as barriers in our materials. Our primary aim is to develop the very best devices we can. So as a result of that, we have to develop new ways of constructing the device, and therefore we need to use the most advanced tools in order to create those devices, from which we will ultimately get a better device and from which we'll eventually be able to commercialize that, because the tools that we have in the Tyndall FlexiFab are industry standard.
Integration of different materials such as germanium and compound semiconductor materials with silicon is the key in the development of active and passive hybrid photonic integrated circuits, as well as in other applications such as in photovoltaics. Having access to different equipments, Tyndall's FlexiFab opens up more fabrication opportunities which allow one to conduct scientific investigations. I'm currently working on integrating germanium with silicon. In Tyndall's FlexiFab, I use the wafer bonder to develop a more simplified and cost-effective integration approach. These approaches are made in an environment that ensures they could be transferred to a production environment.
It's extremely expensive to run a full production facility. For reasons of economies of scale, the large production facilities operate on 12-inch wafers, so they're huge and the costs are absolutely enormous. It costs several billions to build a full fabrication facility that's going to work on 12-inch wafers. But to try out the technologies in a controlled environment, you can do that on smaller substrates. And it's necessary for researchers who are working at the basic research level to have the opportunity with a low threshold in terms of cost to get access to a facility where there is control and yet is very, very much like a production facility. And also for very, very small companies, for SMEs who may have viable processes or viable materials that they want to try out, it would be economically impossible for them to build a fabrication facility to do this. Whereas the facility at Tyndall is an ideal opportunity with a very low cost threshold for SMEs to get access to this type of opportunity and facility. The only way that you can get economic benefit from any of these research topics and new materials that are being researched is that ultimately you get them into production and they become part of the devices, part of the circuits that are part of your laptops or your mobile phones. So they have to be introduced into production lines. Tyndall's FlexiFab offers that complete flexibility. So the FlexiFab, or the flexible fabrication facility, is an ideal opportunity for industry to introduce these disruptive technologies and materials in an extremely controlled environment.